Hello, good morning, my dear thinkers. This is your Tinker Master Srinivas from scientificstudents.com. Today, on this 9th May 2026, I am so happy to develop my thinkers to celebrate this upcoming National Technology Day on 11th of May 2026 in a most innovative way. So today I am going to help them understand the basic circuits and many other circuits to be built. So they have already experienced it through a circuit book and snap circuits, and now I am trying to prepare them to work with breadboard. So that 50 years ago, the way I used to tinker the circuits on breadboard, so my tinkers are also going to be experienced and then start tinkering many circuits, many ideas, various problems they are going to solve on a paper through the schematic drawings, and then later they'll ideate those solutions to local various problems, and then finally they'll test them on the breadboards, and then later once they correct all the solution without any errors, then they will go for a prototype, and then they will go for a product type. So that's how I am trying to build. So now today I am going to explain them how a basic circuit to the complex circuit, all type of electric and electronic circuits, how all those circuits can be built onto this particular breadboard. So how the work area and the power connectivity, all these things I am going to explain to them. So first I will show with a simple LED basic circuit connectivity so that they will have a proper idea how to connect vertical and horizontal, rows and the columns and all with the given number identification and all. And later I will also show the voltage and currents pulled by the various circuits, and also I am going to help them understand about motors and the fans, and then later next time a day after I am going to help them understand a transistor and all, like connecting various terminals of the electronic devices like transistors and ICs and all. And we are going to build on the same breadboard a water level indicator or automatic street light or whatever circuits. I am going to help them understand. Now let me continue how I am going to build it. Okay, you all can watch it and then understand the way I am trying to build it. Okay, welcome my dear mentees. Today we wanted to build. See, here you all need to understand, this is the one we are every day talking about, rows and columns. So here internally, yesterday I have shown you by opening this particular area, like how the backside connections are given. You see, this is what I wanted to show you. You see, my dear friends, how they have inserted metal connectivity. So this is the one. I hope you remember that I have explained clips like this where the component is going inside. So these are the clips. You all can understand that. So this kind of, see how many clips are packed as a group 5, okay. So they are there in the slots. I have just opened to show you all that so that you will understand inside the connectivity. So this is how. So now you can clearly know here inside. From here, these particular columns are internally connected. Okay. So they are the rows. So in this power area, this entire row is already got connected from here to here. So if you give any power here, any voltage here, the same voltage will be here. Are you all following? Similarly for negative connection, if you give any negative connection of the battery here, the entire negative will be there here. Because internally you can see that. You see the continuation, the copper connectivity right from here to there. It is connected horizontally, it is connected like this. That's why I call it as row. It's a row. But however, they are columns. So here on my breadboard, these columns are connected vertically. You see, all they are vertically connected. Is it clear now? That's why I have clearly opened one and I am showing you on my palm. You see, this is the connectivity. They are the clips. So whenever you are inserting any component into that from the top of this particular breadboard, that component will go and it will get arrested between these two clips inside, because the kind of pressure you are inserting, so that will go and the two clips of holding the component inside, okay, like that. So the next time if you are connecting a resistor to the next slot in the same row, the connection internally established like this. So you don't have to give any wiring connections. So the breadboard is so much useful. It is avoiding all your physical connections. Before the breadboards, I used to connect many wires from many parts to the other. But now all the parts can be inserted. If you know the logic, how the internal connections are provided under this, inside this breadboard. Is it clear, my dear friends?
Yes, sir.
Say yes of you.
Yes, sir.
Okay. Now, once this is clear, I am going to remove it. I just opened it to show you how they have sticked in together, how they made, this plastic body, and in which in the slots, like how they have inserted these clips to hold the electronic components and all inside. So I opened it to make you understand all of them. Is it clear? Now I am just going to keep it this one aside, because I don't want this to work with anymore now, because it's going to be now it is another one. Now I don't think I need to open this and show you again, because you have already seen that, right? Now let us work on to this. So my dear friends, you need to understand. So here let me make you understand. Already you know, I don't have to draw the circuit now again. Now you all can tell, okay. So I have a battery positive here. So I have a battery positive. I have the 9 volt battery positive. I am giving you here. See what I did is I have connected 9 volt positive to my breadboard. Yes or no? Tell me.
Yes, sir.
Now you need to tell me that 9 volt positive has to go to whom? You need to tell me.
Resistor.
Oh, resistor or a switch?
Resistor.
What is better for you? Yesterday I said let us go for switch. Why resistor? We can do that anyway, both the ways it works. Okay, so I am taking one switch. I specially made this switch with a single strand of wire where this can be pushed into these connections, right? Okay, now I am going to connect the switch connection. You suggest me whether to insert it in the positive line or negative line, or anywhere I wanted to, I can use that switch.
Anywhere. In the positive.
Huh? As you wish, I have no problem. You can tell me. Anywhere you can tell me. No problem. Wherever you are comfortable, you just tell me. No problem. I can do that. You just tell me wherever you want. I have no problem. I have always alternative solution for everything. You just tell me. Okay, I have connected in the positive row. In the positive row. It is totally positive. The positive will come here everywhere. It is there. If you want, I can show the voltage also. Through the multimeter I can show. Okay, you want to see that?
Sir.
Okay, but before that let me complete the negative connection also. So, you want me to connect negative next to that or somewhere else?
Somewhere else.
Okay, no problem. I can use this track also for the negative. So, I can use this track also. So, battery negative is pushed here into the negative. So, entire negative is there. Now, I want to make sure the battery 9 volt is there in the positive and the negative equally or not. I wanted to make sure that. Okay, now what is that I have? I have made my digital multimeter. I have connected my probes to clip wires. I specially made these two clip wires. So now I am going to insert my clip wire, the negative to the negative track and positive to the positive track. You understand, my dear friends?
Yes, sir.
To make sure my battery is working, and see, I have connected in the entire, anywhere I can connect. Similar, positive I can connect anywhere in the positive track. Now it is showing. And the breadboard is pulled by my two multimeter probe, the self weight. That's why I brought them back. Okay, now you see, my dear friends, the battery voltage is 9.4, maybe 9.5 also, because that is all the way it is coming here and it is connecting there and all that. Okay. So we can make sure the battery voltage is there in the entire positive line and the negative line. The circuit is closed. For the multimeter, the circuit is closed. That's where you are able to see, yes, the 9 volt battery is available in between the positive line and the negative line. Is it clear till then?
Yes, sir.
Okay, now the positive is also going from the positive line to my switch. From the switch it is coming back here. Where you want me to connect this one? I can connect anywhere in the circuit. In the breadboard, somewhere I can connect, wherever I want. So I have inserted this one here. Now the positive has come here. You want to see whether the positive has come or not?
Yes, sir.
Okay, I have another DMM. I can show you on this. Where are the two wires for this? Clip wires. Yeah, I gave you two, no? You kept here. No?
Sir.
Okay. So, for this another digital multimeter, I want to make sure whether the switch is working and connecting the 9 volt to that line. I want to make sure that. So negative of this multimeter, I can push some anywhere in the negative line. Okay, in the entire negative line. Now I can use this one to understand whether my switch is working or not. Already switch is on only. You see? It is showing. Switch is on. Let me switch off this one. So I switch it off. Now, because switch is off, the positive is going to switch, but it is not returning back to the motherboard, the breadboard. That's why this fellow is not able to see the battery positive. If I switch it on, yes, that has come here. Is it clear?
Yes, sir.
Okay, now fine. Now, in this entire basic circuit, yesterday what we have discussed, from the battery positive to the switch and return after the switch, it will go to whom? Resistor or LED or whatever. Which value resistor shall we use for 9 volt for LED? Which resistance we will use? 470 or 220 or 1K? 470. But where is the 470 here? What are the colors required for 470? Yeah, yellow, violet, brown. 470, yes? So where to insert this one? In the positive. In the positive line, here, this positive line. After the switch, they are coming here. So all these are connected internally, no?
Yes, sir.
So that's why I am using. Okay. So now the positive, once the switch is on, the positive will go to switch and from the switch it will come here. And that will go to my digital multimeter also, and also it is now going to resistance. So after the resistance, where it has to go? I don't know that, I forgot that. LED anode or cathode? Positive, that's positive. Positive has to go to the anode, the bill. Anode or cathode?
Anode.
Oh, very good, very good. So, can I connect like this? Can I connect like this?
The same.
No, not in the same column. I am putting into some other column.
The same column should connect.
Very good, very good. Because I have shown you earlier, the connections are there in the same column. So you are going for the next column, then you won't get connection between this particular point to this point. Resistor after, the second point of the resistor won't be getting connected to anode because they are separate columns. So columns, adjacent columns won't have any connection between. Only all the points of one column are internally connected. That's what I have shown you onto this particular. You see, this is one column. So side by side columns are not getting connected. Then you won't get any connections here. That's why what we need to do? What we need to do?
We need to connect.
We need to connect. I have to remove it out and I have to put it in the same Okay. So now, if you want, I can test with the multimeter here whether in this line it's coming or not. If you want to test. Okay. Now, is the circuit is closed now? If I switch it on, I can only see the battery connections are coming to the resistor point because the multimeter is connected to here. So I can see this. But still the lamp is not on, the LED is not on. Even though it is going to resistance, from the resistance it is coming to anode of this LED and it is going to LED and coming out of that LED, but it is not glowing.
It's in reverse.
No, it is not reverse because it is going for anode only. Wrong answer, Arush.
Resistance is not correct.
Resistance connected already. See the resistance connected to the positive supply. If you want, I can touch here and see that voltage, and on the other side also I can open this one and I can show the voltage here. You see the voltage here also it is coming. So after the resistance also the voltage is there. It is going to the LED and it is coming out of the LED. If you want, you can check this also. You can check here also. But still, that is not. It's slightly glowing because that is getting connected through the digital multimeter. That's why it's slightly glowing. But it is not fully glowing. So what I need to do? What is mistake? What is the mistake? From the cathode, where it has to go in the basic circuit. That is what is your missed.
From the cathode to the negative.
Negative. But have you connected from the cathode to negative line? Have you connected? So that is whose fault is that? But why you have not done that? So I am connecting the cathode of the LED to the negative line. But even still it is not working. Who is going to find the problem? There. Oh, switch is on or not? Yeah, it is on. Switch is on.
Connected, you do the same way.
Someone has to find out. The LED connection is grounded. It's grounded. It's grounded. But it is not on.
You didn't connect in same column.
All the time he is on. What is your name?
Akils.
Akil only answering that. He only understood the breadboard connections properly. That's why I opened totally one breadboard totally, and I have shown you how the columns are with the same material, so that the components will get connected in the column. That and all are very clearly shown. I did a total kind of surgery for this breadboard. But still you are not able to understand. So it shouldn't be the case like that. So what I need to do? I need to do connect what? I did a mistake here. So now even then it is not glowing.
You didn't connect.
In the same line it is there, in the same row it is there. Column. How many people say, my mistake is not that row thing, that it has to go in the column. Which column it has to go? So, LED column. LED cathode column or anode column?
Cathode.
So, now, in the same cathode column, when I have inserted the negative jumper wire, from then connected to the negative, that's it, the circuit is on. So, voltage is 2 volts at the anode of LED, 2 volts. That means this resistance exactly working to drop almost 7 volts because it's 9 volt battery. See, 8.94 is 9 volts. So, 9 volts minus this 2 volts is nothing but 7 volts. That is dropped across the resistance. If you have another digital multimeter, if you measure the voltage across the resistance, that will be 7. So, voltage across the resistor, voltage across the LED is equal to voltage of the battery. And also, you can connect one current meter in between anywhere in the circuit, positive to the breadboard, or it is between the switch, or from the resistance in between, or anywhere. Even you can remove this one and connect a ammeter here from this line to this line. Then also you will see the current, because current everywhere in the circuit is the same. So that yesterday we have measured, that has shown 20 milliampere. Yes or no?
Sir.
So now you can say this way. My dear friends, the current through the LED is 20 milliamperes and voltage across the LED is 2 volts. Now what is the power it is getting consumed over there with this LED light? The 20 milliampere into 2 volts. So power of the LED, the power getting dissipated, the power getting consumed across this LED is nothing but P is equal to V into I. So V is 2 volts, I is 20 milliamperes. If you multiply the both, then you will see how much power you are consuming to get that much of light. Now I have some interesting thing. Now I wanted to make sure, this is another most interesting. I have 2 more LEDs here. Now I wanted to see whether the yellow one is also drawing the same current or the green is also drawing the same current. All the colors are drawing the same current. This is another question given to all. So on Monday morning you will see the difference. And let me change this right now. Now I am going to connect it. The yellow. It is not glowing. Why? What is wrong? No, not reverse. I have connected anode to anode only. There is some problem. Who is going to detect the problem?
It's not in the same column.
So okay. Now I am going to replace this one and see.
It's not in the same column again.
Happy? So this is how you need to understand. Suppose if I remove, suppose in the same case, if I wanted to connect the red one also, so I can do this way. Now the red one is coming bright, but the green is now very much dim. That means this fellow is drawing more current than that one. The whatever current is required to come green on, that is not available because of the resistance. And if I put another resistance parallel to that, then the current will be available for the green and the red as well. So this is how you need to understand current in different paths. That's also different to next level. I will be training you to that level. But now just I have connected another LED parallel to that, and at the same time you have seen, you see, when I removed a parallel LED, red LED from that circuit, and the green is beautifully working. That means whatever current this resistor is allowing, the 20 milliampere, that is sufficient enough only for one LED. And next time when you connect parallel to that LED, and this fellow is drawing more current, maybe 15 milliampere, and that fellow is getting only 5 milliampere, because of which that's not sufficient enough to glow. You all understand, my dear friends?
Yes, sir.
Now, what I wanted to do right now, I wanted to remove all this fellow. I haven't checked up this one. Yeah. So whenever I am switching off, the positive is not coming to the resistor point. That's why it is not forward biasing. That's why it is the control, switch control. You see, when I am switching off, there is no voltage for the LED. But the battery voltage is there. But when I am switching on, when the LED is on, when the LED is drawing the current and the battery voltage is going down because it is pulling current. If the battery is good enough, then that won't go. That will be maintained. That and all with a constant voltage source like regulated power supplies and all. That we can, SMPS power source. That and all, we have them. I will show you next class. Okay, is it clear? Now do you want to test with motor also? Yeah, we can do that also. Now, I have a small motor here and then I have connecting wires for the motor, so we can connect. Okay, a motor is connected. So, now I am going to connect this one into the negative track and now this one into the positive. Where you want me to connect? It is running. Even without switch on also it is running. Yeah, you see? Hold it. Hey, why are you pulling all my setup? Why are you pulling all my setup? Okay, now you see, I am just putting some anywhere. Gautam, observe this. Running? Without switch on also it is running. Why it is running? Gautam, hold it like this. See, now, without switch on also it is running. Who is going to answer me this?
Because the positive is flowing.
Yeah, in the positive line, the input line, before the switch only I am connecting the positive. Negative already connected. And without switch, now if I put this one here, and it will wait for the switch, because it's after the switch. Okay. See, now it's not running. Okay? Yeah? It's after the switch.
Sir, it is also coming and it is stored into the LED.
Because it's pulling more current. That current is not sufficient enough. Okay? And this is before the resistance. If I put it after the resistance, hold it. So now I am going to connect the positive of the motor after the resistance. What happens? Fan is not running. The light also is not coming. Though I have switched it on, everything is ready. The battery voltage is down. The battery voltage is there. But the voltage after the resistance is not showing. Whatever is coming there, that is now grounded. Because of this motor, low impedance, more load resistance. So it is not running. Because the required voltage is not there after the resistance. Because resistance is very high, 470. If I reduce to 10 ohms, yes, that is sufficient enough to give the required current. Because now high value, I have to reduce it to low value. That's where required current will be passed. You understand what is that? So for the motor, now what I will do, I will remove the motor wire, right? You see? Now whatever current required for the LED is sufficient enough through the 470 ohms. Is it clear now?
Yes, sir.
So this is how you need to understand. Now I am going to connect before the resistance to make you understand something more interesting. Okay. Now whatever current required for the motor, it's available because there is no resistance in between. It is directly going from the switch. You see, switch is under control now. I can off it. Yeah, yes or no? I am going to on it. Now you observe one more interesting point. Open it. See, another most interesting fact I am going to show you. I did some magic here. What is the magic I did?
It's turning reverse.
It's turning reverse. What is that I did? You observe this. See. What is the magic I did?
Turning reverse.
So, if you reverse, in the motors, the direction will be reverse. Because DC motors, they are the DC motors. You understand? Is it clear for all of you?
Yes, sir.
Now, can I short this too? This is the positive of the battery. After the switch, it is negative directly. Can I short this too? Even battery, that LED also will be down because the entire circuit, the battery output is getting shorted. You see, like this. You see, the battery voltage, the LED across voltage, and you see the battery voltage is also going down. You see, everything is going. So it's called short circuit connection. Short circuit circuit. We should never do like this. Okay, short circuit should not be taken place. That's why we say that many things when they go bad, we'll simply say short circuited. That means the internally everything connected direct plus minus and all. Okay, that and all we'll understand later. Okay, so we should never do. We always should do with the proper resistance load or design loads and all. Okay, so is it clear? Now we understood how to establish connections, required connections. Okay. On a breadboard. So if I give any drawing on a paper, you can use the breadboard and take the components and connect and show me. So Monday, if you wish, I can bring transistor and then we can connect. Remember me. We can connect. Suppose say one resistance and let every we have two three more resistors. So we can connect all of them and we can give resistors more and we can see all of them parallelly working. That's what one video I already shared with you. Okay, is it clear now?
Yes, sir.
So that's one thing, and I wanted to explain you guys like how water level indicator can be established on a breadboard. If you know that much, then we can play with the breadboards like anything. So one transistor connection, and then required resistor connections, LED connections, and all that I will show you on a breadboard. And then later, any idea, any circuit can be connected across the breadboard, and you all can enjoy working with breadboards like this. Bigger one, much more bigger one. You can have one more breadboard here. That's where these slots will help you connecting them and all that. Okay, then I hope you all enjoyed today's session.
Yes, sir.
So, what are all the various things we have discussed right from the morning and all, you will be writing on a today's notes, okay? Then, can we say good for the day now?
Yes, sir.
Okay. Okay, my dear Tinkers of the Nation, signing off, your Tinker Master Srinivas from scientificstudents.com. Bye-bye.